b 3, n plus 1, b n plus 1, equals n, b 1 plus 2 plus 3 plus n, comma, n plus 1, equals n, b n plus 1, 2, n plus 1, equals n, b n2 equals, a 1 2 b 1 2, n equals, ob. N equals nth power of the GM between A and B. Solved examples. Example 1. Insert 3 GMs between I, 3 and 432 2, 1, 9, and 9. Solution, I. Let G1, G2, G3 be the 3 GMs between 3 and 432. So, 3, G1, G2, G3, 432 are in GP. Let R be the common ratio. T5 equals 3, R4 equals 432, R4 equals 144 equals 23, 4R equals 23. Now, G1 equals at R equals 3, 2 3 equals 6, 3 G2 equals at R2 equals 3.12 equals 36, G3 equals at R3 equals 3.243 equals 723. Hence the required GMs are 6 3, 36, 72 3, 2. Here, 1/9, G1, G2, G3, 9 are in GP. T5 equals 1/9. R4 equals 9, R4 equals 81 equals 3, 4R equals 3. Hence the required GMs are R, R2, R3. G1 equals at R equals 1/9, X3 equals 1/3, G2 equals at R2 equals 1/9, X9 equals 1, G3 equals at R3 equals 1/9, X27 equals 3. So, the required GMs are 1/3, 1, 3. Example 2. The AM between two numbers is 20 and their GM is 16. Find the numbers. Solution. Suppose the two numbers and B. So, AM equals A plus B, 2 equals 20, A plus B equals 40, 1, and GM equals OB equals 16, OB equals 256, 2. Now using the identity, A, B, 2 equals A plus B, 2 for OB, we have B, 2 equals 40, 256, B, 2 equals 1600 to 1024 equals 576, B equals plus or minus 24. Solving 1 and 3, we get A equals 32, B equals 8 or A equals 8, B equals 32. Hence, the required numbers are 8 and 32. 3. 1.14 Applications of arithmetic and geometric progressions. Example 1. For 3 consecutive months, a person deposits some amount of money on the first day of each month in small savings fund. These successive amounts in the fund deposited, the total value of which is R65, form a GP. If two extreme amounts be multiplied each by 3 and the mean by 5, the product forms an AP. Find the amounts in the first and second deposits. Solution, let A, R, R2 be successive amounts deposited. Then, A plus R plus A R2 equals 65, and 3A, 5R and 3R2 form an AP. Thus, by the property of AP, we have 3 of 5R equals 5R 3R2, 3R2 10R plus 3 equals 0. 3R2 10R plus 3 equals 0, R3, 3R1, equals 0, i.e., R equals 3 or 1/3, I. For R equals 3, from I, we have A plus 3 A plus 9 A equals 65, i.e. 13 A equals 65 and A equals 5. Thus, the amounts are Rs 5, Rs 15, and Rs 45. Again, if R equals 1/3, then from I, we have A plus A/3 plus A/9 equals 65, i.e., A equals 45. Thus, the amounts are 45 rupees, Rs 15, and Rs 5. Hence, the amounts in the first and second deposits are Rs 5, Rs 15, and Rs 45. Example 2. The value of a machine depreciated each year by 20%. If the percent value of the machine is Rs 18,750, then find the estimated value at the end of 5 years. Solution, I depreciation for the first year equals 18,750 x 0.20. Thus, the depreciation value of the machine at the end of first year is 18,750, 18,750 x 0.20 equals 18,750, 020 equals 15,000. 2. Depreciation for the second year equals depreciation value at the end of first year, x, rate of depreciation for second year, equals 18,750 x, 1/020, 0.20. Depreciation value at the end of the second year is, equals, depreciated value after first year, depreciation for second year, equals 18,750x, 1 to 0 20, 18,750x, 1 to 0 20, 0.20, equals 18,750x, 1 to 0 20, 2. Similarly, depreciated value of the machine at the end of third, fourth and fifth year is 18,750x, 1 to 0 20, 3 18,750x, 1 to 0 20, 4 and 18,750x, 1 to 0 20, 5 respectively. 1.15. Summary. Quantitative techniques used to solve the complex problems that come in business or industrial area. For doing this we have many techniques. We are having many techniques according to the problem. For example, to solve the problem related to profit and loss we are having profit function. For solve the problem of demand and supply we have demand and supply function. This function decides the cost of the product according to the demand of market. For finding revenue cost we have revenue cost function. For find out production from a raw material we have production function. The production function helps in decision making too. It can tell us that how many people we need to run an organization, how much capital we needed, etc. By using consumption function we can estimate our consumption. Quantitative techniques not only help in business or economics, there are some special functions also. For example, we have polynomial function, even and odd function, rational and irrational function, one-to-one function, onto function, into function, many to one, many to many, one onto, one into, and then we have composition of functions. This helps us in information technology field, as well as in banks and many other areas too. It has a very important role in today's global economy. People are doing research in this area. It is the fastest growing technique for business sector. In every area functions helps us to solve our real problems. It also helps in proper deployment of resources, minimizing waiting and servicing costs, choosing an optimum strategy, optimum resources allocation, helps in decision making of management like in purchasing and decides the price of a particular product. 1.16. Keywords. Quantitative technique. It is a tool to help in decision making and problem solving. Demand. Quantity demanded of a particular commodity by the buyers. Supply. Handed particular commodity to the consumer that has been produced for them. Cost. Fixed and variable cost at the time of producing a particular commodity. Revenue function. The total revenue in a particular commodity of a firm is depending on the number of units sold. Profit.